Hello viewers, in this video I will find out the reactions for the cantilever beam, for the point load acting over the cantilever and the UDL is acting over the cantilever. So first of all I will solve this for the point load and then for the UDL case. The reactions for the cantilever beam. So what I will do, here in this case the VA is acting upward, the reaction, vertical reaction, HA is the horizontal reaction and MA is the moment reaction. So what I will taking moment about point A. This is my point A, I will take moment about this point. And the summation of all the moments about point A is equal to 0 and the counterclockwise moment is taken as positive and clockwise moment is taken as negative. And this is my point A and moment is actually equal to force into moment arm. Here you can see the 10 into 15. 10 is the force, this force point load, and 15 is the moment arm of this force about point A. The vertical distance of this point of application of this force and this point A. The vertical distance between these points is the moment arm. Here this point load create the clockwise moment about point A, so that is why we have taken it as negative over here. MA is creating the counterclockwise moment about point A, so it is taken as positive. You can see only these two moments are acting. This force creates the moment and this MA is the moment about point A. This VA and HA are passing through A. So in this case for these two forces moment arm is 0. So that is why they do not create any moment about point A. Only MA and 10 keep create the moment about point A. And MA is actually the moment, so we don't need to multiply it with any moment arm or something. The sum of these two moments equal to 0. And here we will get MA is equal to 150 kip feet. This is the MA is acting over here. Now I will find out this VA acting upward. For this I will take sum of all vertical forces is equal to 0. The upward force is taken as positive and downward taken as negative. This 10 kip is acting downward, so taken as negative, and this VA is acting upward, taken as positive. You can see only the two vertical forces are acting over here. One is 10 kip, second is VA. So their sum is equal to 0. Thus I will get VA is equal to 10 acting upward over here. So these are the reactions for my cantilever with point load acting on the cantilever. Now here the horizontal reaction, you can see it is 0 because in this cantilever no horizontal force is acting. So if any horizontal force acting over here, this horizontal force is directly equal to this horizontal reaction over here. So now I will find out the reactions for the cantilever when UDL is acting on it. So similarly I will take the moment about point A and 3 into 20 is the UDL force and 10 is the moment arm for this UDL force. 10 is the half of this 20 is the moment arm of this UDL force. This creates the clockwise moment about point A, so that is why I taken it as negative. Plus MA. MA create the counterclockwise moment about point A, taken it as positive. You can see only these two forces create the moment about point A. So that is why I have taken only these two forces and their sum, only these two moments and their sum equal to 0. This VA and the horizontal acting over here are passing through point A, so they do not create any moment. Only this UDL create moment and this MA is the reaction moment about point A. This MA is equal to 60. It is acting over here. Now I will proceed for this vertical reaction. For this, similarly, I will take sum of vertical forces is equal to 0. The 3 into 20 is the UDL vertical force acting downward, taken is as negative, and VA is the positive acting upward. There are only these two vertical forces acting on this cantilever, so their sum is equal to 0. In this way, I will get VA is equal to 60 acting over here. And the horizontal reaction in this case also is equal to 0 because no horizontal force acting over here. So these are my two cantilevers and these are their reactions over here. In this video, I will find out the reactions of beam for UVL. This UVL is acting on the 20 feet span. First of all, I will take the moment about point A. This is my point A, and summation of moment about point A is equal to 0, and counterclockwise is taken as positive and clockwise moment is taken as negative. The moment is actually equal to force into moment arm. This VB multiplied by 20. This VB is the force and this 20 is the moment arm of this force about point A. This VB create the counterclockwise moment about point A, so this taken as positive, and this 20 is its moment arm of this V. This 5 into 20 divided by 2 is the UVL force, and this 20 by 3 is the moment arm. This UVL force into moment arm is the moment. This is 20 by 2 is the moment arm of this UVL force about point A. This create clockwise moment. This UVL create clockwise moment about point A. So this is taken as negative over here. Here you can see only the two moments are acting about point A. One is due to VB and the second is due to UVL force. And this VA do not create any moment because it is passing through point A. So it do not create any moment. So only two moments are over here. The sum of these two moments must be equal to 0. And arranging it, I will get VB is equal to 16.67. Here the VB is acting 16.67 upward. And now I will proceed for the VA. I can find out the VA by the same method by taking the moment about point B, and I can also find out the sum by taking the sum of all vertical forces is equal to 0. Here the upward force taken as positive and downward force taken as negative. Only the vertical forces are considered over here. The VA is acting upward, taking it as positive, and 16.67 acting upward, taking it as positive, and 5 into 20 divided by 2 because it is UVL, it is acting downward, taking it as negative, and their sum is equal to 0. You can see that only in this shape only three forces are acting: VA, VB and this UVL. These three forces are taken over here, and VA is equal to 33.3. Arranging it, we will get VA is acting over here upward. So these were the simple reactions for the UVL. In this case, there is roller and pin, so no moments are acting over here and no horizontal reaction are acting. Only the vertical reactions are acting in this UVL case. In this video, I will explain you how to find out the reaction for this type of loading. In this case, the UDL point load and UVL acting over the beam, as you can see. Let's proceed. This is my UDL, and this is taking moment about point A. This is my point A, taking moment about this point. Summation of moment is equal to 0. Taken counterclockwise moment or anti-clockwise moment positive and clockwise moment negative. Moment is equal to force into moment arm. Let's proceed. This is my force value. 2 is the UDL value and 5 is the span upon which the UDL is acting. 2 into 5 is my downward UDL force acting multiplied by moment arm. The 2.5 is the moment arm. Because this UDL does act at the center, at the midpoint of this 5 span. So that is why this is taken as this one. And this UDL create clockwise moment about point A, so taken as negative. This is my point load acting at distance 10 feet from point A, so taken as point load concentric load value into moment arm, taken this value as a negative because this also create clockwise moment about point A. So let's proceed for the UVL. This is my UVL. UVL value is 4 into 5 into 0.5. This is the UVL value acting downward, and this is my moment arm. UVL value is the force multiplied by moment arm. This 5 plus 5 plus 5 plus 5 by 3 is the moment arm value. How we have taken this 5 by 3, I will tell you it now. This UVL also create clockwise moment about point A, so that is why this also taken as negative sign. Now I will explain you how the moment arm for the UVL should be taken. Taking the moment about point A, this UVL value, force value acting downward. If we are taking moment about point A, in this case the 5 by 3 will be the moment arm. For this UVL case, this is the force into this is the moment arm. But if we are taking moment about point B, then what will be the moment arm? Then 5 into 2 by 3 will be the moment arm. Because in this case load, UVL load acting here from B, the distance of the UVL force acting will be 5 into 2 by 3. So that is how I have taken the 5 by 3 from this point. This distance is 5 by 3. Adding this distance in this 15 feet, I will get the moment arm. This VE is also, this VE create the counterclockwise moment about point A. That is why I taken it as a positive into 20. 20 is the moment arm of this VE equal to 0. Summation of all the moments equal to 0. Thus arranging this equation, I will get this equation, and VE is equal to 14.58. In this equation only VE is the variable, so we can find out VE is 14.58 Gibbs. We will proceed to find the VA. VE is acting over here and VA is acting over here. Sum of all the vertical forces is equal to 0, and the force, upward force taken as positive and downward force taken as negative. So this 2 into 5 is the UDL force acting downward, so taken as negative. This 10 is also acting downward. This UVL force 4 is the UVL value, 5 is the span, and multiplied by 0.5 because it is the UVL acting downward taken as negative. So, and this 14.58 is the VE acting upward, is equal to plus VA is also acting upward, so taken as positive. VA and VE taken as positive because both are acting downward, and these three forces 2 into 5, 10 and 4 into 5 into 0.5, these three forces acting downward, so taken as negative. Okay, now arranging this equation, I will get this equation. VA is equal to this one. The VA is 15.4 Gibbs is the VA value acting over here. So this was the simple video how we can find out. This is the example that you have to solve by yourself, and this is the second example that you can solve for the practice. In this video I will find out the reactions when the reaction for the simply supported beam when the moment acting on it. This is the clockwise moment acting and this is the counterclockwise moment acting. I will solve them separately. First of all, I will solve this clockwise case. So what I will do, I will take the moment at point A. This is my point A, and the summation of the moment is equal to 0, and counterclockwise moment is taken as positive and clockwise moment is taken as negative. And the moment is actually equal to force into moment arm. This is my point A about which I am taking the moment. This VA is the force and 20 is the moment arm of this VA about point A. Moment arm is actually the vertical distance of the point of application of force and the point where we are taking the moment. The vertical distance between these 2 points is the moment arm. Here the 20 is the moment arm for this VA. So multiplying it with 20, I will get this moment, and it is positive. It is taken as positive because it creates the counterclockwise moment about point A. If it is acting downward, then it could create the clockwise moment and we will take it negative. But now here it is cut. This VA, the moment created by this VA taken as positive because this moment is clockwise moment about point. The moment created by this VA is positive because it is the counterclockwise moment about point A. And 50 is the moment it is clockwise moment about point A, so taking it as negative. Their sum is equal to 0. You can see here only these 2 moments are acting. The first moment is due to this VB, this, and the second moment is 50 acting. Their sum must be equal to 0. Here VA do not create any moment because it is passing through the point where we are taking the moment. So here the sum is equal to 0. The sum of the moments is equal to 0. Here we will get VB is equal to 2.5. It is acting over here. Now I will, for VA, I will take sum of all vertical forces is equal to 0. The upward force taken as positive and downward taken as negative. The 2.5 is acting upward and VA is acting upward also. Taken both as positive, their sum must be equal to 0. You can see only these 2 vertical forces are acting on the beam. This 50 is actually the moment. It is not the vertical force. Only these 2 vertical forces are taken over here. And VA is equal to minus 2.5 acting over here like this, and I will reverse its direction and it will become positive. These are the reactions for this beam, and for this I have solved now for the clockwise case, and for the similarly you can solve for the counterclockwise case. Thanks for watching my video.